For most of human history, we pictured the universe as a giant, rigid box. Space was just an empty stage where planets and stars sat, completely still and unchanging. We also thought time was a massive, invisible clock ticking away in the background. It made sense to assume that a second for you was exactly the same as a second for someone across the galaxy. Space was where things happened, and time was when they happened. They were two separate, fixed backgrounds that didn't interact at all with the planets or stars inside them. Then, in the early 1900s, Albert Einstein realized that our common sense was wrong. He proved that space and time are actually woven together into a single, stretchy fabric. We call this space-time. Because this fabric can bend and flex, reality starts doing things that sound impossible. Traveling at high speeds can physically slow down your clock, and heavy objects can warp the space around them. Einstein's first big discovery, special relativity, revolves around one strict rule: the speed of light is always constant. No matter how fast you are moving, light always travels at about 300,000 kilometers per second. To understand why this changes everything, imagine a clock that uses a bouncing beam of light to measure time. If that clock moves past you at high speed, the light has to travel a longer, zigzag path to hit its mirrors. Since light can't speed up to cover that extra distance, the ticks of the clock must take longer to happen. This leads to a famous thought experiment involving two twins. One stays home on Earth, while the other takes a journey in a rocket ship traveling near the speed of light. When that ship finally returns, the traveling twin may have aged only a few months, while the twin who stayed on Earth has aged many years. Because the traveler was moving so fast, their experience of time literally slowed down. It proves that a second isn't the same for everyone. It depends entirely on your motion. 10 years later, Einstein redefined gravity. He showed it isn't an invisible force pulling objects together, but a physical curve in the fabric of space-time. Think of space-time like a stretched trampoline. If you place a heavy weight in the middle, the fabric sags down, creating a deep bowl. Our sun creates a massive dent just like that. Earth stays in orbit because it is like a smaller ball rolling along the rim of the sun's curve. Gravity is simply the result of objects following the natural slopes and valleys created by heavy mass in the flexible stage of the universe. Einstein found that this flexibility reaches far beyond planets and stars. The entire universe is actively stretching out. Galaxies aren't flying through space. The space itself is actively stretching out between them, like an inflating balloon. This flexibility even extends to matter itself. Einstein's most famous equation, E equals mc squared, shows that mass and energy are just two forms of the same thing. This explains how the sun shines and nuclear plants produce energy, by turning tiny amounts of physical mass into massive amounts of heat and light. Matter, energy, space, and time are not separate ingredients. They are interchangeable parts of one connected, dynamic system. You can see these abstract rules in action every time you use the Maps app on your phone. GPS satellites orbit Earth at high speeds. Because they are moving so fast, special relativity tells us their onboard clocks tick slightly slower than clocks on the ground. At the same time, they are floating far above Earth's heavy gravity curve. General relativity shows that being in weaker gravity actually causes their clocks to tick faster. Scientists must use Einstein's equations to correct these competing shifts, so the satellite clocks stay perfectly synced with your phone. Without calculating for the flexible nature of space-time, our global GPS systems would become hopelessly inaccurate within a single day. We do not live in a rigid box with an unchanging clock. We actually live in a universe where speed clearly changes time and mass shapes the space around it. So the next time you use your GPS, remember that you are navigating through a universe that bends and stretches.